Yes. Okay. Great. All right. So this is the Nutanix Prism GUI. This is all HTML5 based, so there's no Java, there's no Flash plugins either. We're going to go ahead and log in with our default username and password, and it will actually go ahead and ask us to change the password. Admin. There we go. And then we'll go ahead and put in the new password. Of course, we have to fill out the great EULA. And first thing it'll actually tell us is that Pulse is not enabled. So Pulse is our phone home feature. That's where it actually go ahead and sends alerts, critical alert statistics back to our Nutanix support system. And so that way, this is how we get proactive alerts in case there's any issues with the Nutanix system itself. I'm going to actually go ahead and enable Pulse. And here is our home screen here. So we're running, as you can tell, we're running our Acropolis hypervisor here. And with our current version we have. And this actually will give us now our total storage summary that we have on the system. You can see here that we have about 60 terabytes total free with nothing used right now, obviously, because we just went ahead and created this from scratch. We actually can take a look in to see what the actual VMs are, right? So this is whether it's going to be Acropolis hypervisor, Hyper-V, or VMware. We can actually go ahead and take a look and see what actual VMs are on here and get stats from that as well too. So in this case, we have Acropolis hypervisor, we have our 3 controller virtual machines showing up here as well too. Over here is our hardware summary. We can see that we have 3 hosts, 3 blocks, and they're all the HX5500 series model number here. Up here in the middle, we see the cluster-wide IOPS, I/O bandwidth and latency. We can actually, if there are any stats on here, we can actually go ahead and hover over those stats, and it'll actually go ahead and pop up and tell you what the stats are for that particular time period when we actually have some stats. And then over down here, we can see what our overall CPU usage for the entire cluster, as well as overall memory usage for the entire cluster is as well too. Over here in the middle is our health alerts page. So this tells us if there's any critical alerts with the system, warnings, etc. Over on the bottom is our data resiliency status. So this tells us if our data is completely redundant or not. And if it's not, it'll tell us if it's in rebuild or what the issues are as well too. And if there's enough capacity left to do a full rebuild, if we did lose an entire node on the system as well too. Again, all alerts show up here on the right. We can also get alerts here from this drop-down menu here as well too. So I'm going to go over into the storage page, and when we go to the storage page, this is a storage-centric view of the entire Nutanix system itself. So we'll see here how many containers we have, the capacity optimization. This tells us if we have deduplication or compression turned on, and we can see the overall cluster IOPS, I/O bandwidth, I/O latency, and how much deduplication that we have on this particular tier here as well too. Any storage-specific alerts will actually show up here as well too. And actually, I go over to the table, and here is where we actually have we configure storage. Now, because we actually went and did this via the Foundation platform, we had actually automatically created a storage pool and container for us automatically. And so, really quickly, we have the concepts of storage pools and containers on Nutanix. Storage pool is basically a collection of physical disks. So in this case, on Nutanix, there's only a single storage pool that you would need, and that storage pool contains all the SSDs and all the spinning disks for the entire cluster itself. There's actually no need to create additional storage pools. The storage pool concept was actually around in case, for some reason, there was some sort of kind of odd government or regulation where you needed to have your storage separated on separate physical devices on the system itself. Nowadays, actually, that doesn't really exist anymore, but that storage pool is kind of a holdover concept from back in those days. However, we do have containers. And a container is a logical separation of your data. So each container is also equivalent to a data store for each individual hypervisor as well too. So if we're running ESX, each container would be equivalent to a NFS data store. If we're running Hyper-V, each container would be equivalent to an SMB data store. Or since we're running Acropolis here, each container is equivalent to an iSCSI data store. And each hypervisor has its own storage protocol methods that it accesses the storage itself as well too. But if you wanted to go ahead and create a storage pool, we will just go ahead and click on, actually, I'm going to go ahead and delete all these containers, and I'll go ahead and create these from scratch again to show you actually how to actually create these things. So I'm going to delete this container, and then I'm going to go ahead and delete this storage pool. All right, now that all the containers and storage pools are deleted, to actually go ahead and create a new storage pool, I will click over this plus storage pool button over here, and I'm just going to give this a name. So I'll call this SP1 for storage pool 1, and there's a checkbox here that says use unallocated capacity. That's automatically checked by default, and it's going to use all my available disks I have in the entire cluster itself. So that's all the SSDs and all the spinning disks. Click on save, and it's going to immediately create the storage pool. The next thing you want to do is create a container. So I can go ahead and click on this plus container button over here and give this container a name. I'll call this container 1. It's going to automatically select my storage pool for me. In this case, I only have one, so it's automatically going to select that. At this point, I can go ahead and click on save, or I can actually go into advanced settings with containers. And so we can actually go ahead and create multiple containers. And one of the big reasons why we actually want to create multiple containers is because we can set properties for each container as well too. So here we can actually see that we can set the replication factor per container. Now, by default, we do a replication factor of 2, which means that we store 2 copies of your data on the system across the entire cluster. If you have 5 or more nodes on the system that you bring up and create the cluster at the same time, we can actually set that cluster to replication factor 3, where we store 3 copies of your data on the entire Nutanix cluster at the same time. This way we can tolerate, with RF2, we can tolerate 1 node going down, or N+1 redundancy configuration. With RF3, we can tolerate 2 simultaneous nodes going down, or N+2 redundancy configuration as well too. Now, we can actually set that on a per container level. So that means I can actually have 1 container, or basically 1 group of VMs set to RF2, and then I can have another container with my group of VMs set to RF3. This way I can have my more important VMs set to a higher redundancy factor. Obviously, creating RF2 or RF3 means that I'm using 2x or 3x the cost of disk space to actually go ahead and do that. So setting things to RF3, there is a price to pay for that in terms of the cost for the VMs. Now, what we can also set is erasure coding per container as well too. And erasure coding is very similar to RAID or software RAID. And what that does is basically split up instead of having an RF2 where we store 2 copies, or RF3 store 3 copies of your data, what we do similar to RAID 5 or RAID 6, where we actually split things up into data bits and parity bits. And that actually allows us to maintain the N+1 or N+2 type of redundancy, but utilize significantly a lot less space, because we're now striping up to data bits and parity bits as well too. And again, we can turn this on a per container basis as well too. We can also turn on our reserve capacity and advertised capacity. So by default, all the containers are thin provisioned by default. So that means if I create 10 containers, I'm going to have the same amount of, I'm going to say if I create 10 containers, each one will actually say that I have 10 gigabytes of space free. That doesn't mean I actually have 100 gigabytes of space free total. They're all thin provisioned, so we're all seeing the same amount of free space. But however, on each container, I can actually create a reserve capacity. So I can reserve a certain amount of capacity, and I can actually go ahead and set my advertised capacity as well too. So that way I can set a smaller advertised capacity or maximum capacity for that container as well too. Now we also have deduplication and compression, and that's also set on a per container basis. So we can actually have 2 ways that we do duplication. We have what we call our performance tier deduplication. So that's where we duplicate over on the SSD tier and on the memory tier. That effectively gives us a larger SSD working set size and a larger cache working set size. That in effect gives us actually a higher performance, because we can actually have more SSDs and more cache on the system. And that actually negates some of the negative performance hits that we get by turning on compression or deduplication, because of the extra CPU hit we get for deduplication. After that, we also have capacity tier duplication. So that's where we deduplicate over on the hard drive tier for more capacity over on the storage side. And that is actually a background task that we do, and that's also distributed across all the nodes in the system. And so we're using our MapReduce algorithm for that, where we actually can take that particular workload and spread that out across all the controller virtual machines in the entire cluster. This way we can take advantage of the multiple controller virtual machines that we have in the entire cluster, and the more nodes that we add to the cluster, the more horsepower we get, and the faster that it actually gets as well too. So we can go ahead and turn on capacity tier deduplication, and then compression as well too. And again, the compression is one of those tasks that are actually very CPU intensive as well too. And again, because we can go ahead and use our map reduce algorithm, we can actually set that up and distribute that to all the controller virtual machines. So that way when we turn on compression, when we turn on deduplication, it won't actually have a negative, a big impact in performance on the system, because we're able to go ahead and spread that load out across multiple controller virtual machines. And again, the more nodes that we have in the cluster, the more power that we have for the entire process to go, and the faster everything runs as well. So when I turn on compression, I have the ability to go ahead and put a delay, because we actually offer both inline compression and post-process compression. So inline compression, if we leave it at 0 minutes, that's inline compression. Well, if we put in a number here, it'll actually go ahead and do post-process compression and delay the actual compression part until X number of minutes on the system as well too. And we also have the file system whitelist, where we can actually go ahead and whitelist other servers to actually access this container as a NFS, iSCSI, or SMB share. And the file system whitelist is really only used for migration purposes when we migrate your old data from your existing systems onto Nutanix systems. We don't actually allow you to actually run VMs on Nutanix from other systems as storage itself. At least not quite yet. So I'm going to click on save, and that's actually going to immediately create this container for me. So since I'm running AHV, it's already included in this entire process. But if I was running ESX, it would actually go ahead and mount this container as an NFS data store across all the ESX hosts in my cluster for me automatically, without having me to go to each individual host and then going ahead and add this NFS share manually. All right, now that we've gone ahead and created a container, that's pretty much the end of managing your storage at this point. You've created a container, now it's been presented to the hypervisor, and what you used to have to do in your typical legacy environment, if you're running a fiber channel NAT or fiber channel storage or any type of basically just pure storage, you would have to go ahead and set up your RAID groups, you'd have to go set up your online spares, you'd have to go set up your your LUN zoning, you have to do manage the WWNs, and then go ahead and carve out LUNs from different RAID groups and manage the hot spares depending on number of spares on this number of disks you have in the system, which can take an extremely long amount of time. It actually may take literally weeks to months to actually go ahead and provision your storage. Here at this point, I've gone ahead and created all my storage and ready to go with just actually a few clicks at this point. And now storage allocation's done, and I'm ready to actually go ahead and provision virtual machines at this point. And here I'm actually running Acropolis Hypervisor. So actually I'm going to go over onto my VM screen here, and here's actually a VM-centric view of the Nutanix system itself. Now, because I'm running Acropolis Hypervisor, I can do a lot more with this and actually manage VMs within the Prism interface here. But whether it's going to be a Hyper-V or ESX or AHV, the actual interfaces all look the same, and we can get pretty much the same information as well too, because we actually get statistics directly from the hypervisor, and we actually load it into the system itself here as well. So here, if you have VMs loaded in your system, we can actually go see the names of the VMs, the hosts. We can actually go ahead and get stats like CPU memory, CPU usage, memory usage, controller IOPS, et cetera, stats that we're pulling in directly from the hypervisor across all three hypervisors as well too. I'm going to actually come back to VM in a second and go over on the hardware side. And so this is a hardware-centric view of the Prism of the Nutanix system itself. Here it'll tell me I have 3 hosts, 3 blocks. I have 3 of them monitored, how many disks I have, what are my top hosts by disk IOPS, by disk IO bandwidth, by memory usage, by CPU usage. I can actually go ahead and click on the diagram view, and it will actually give me a diagram view of what my actual physical system looks like. And here I can get my performance summary of the entire cluster itself. Now that we've given it some time, we can actually see that there is some CPU usage, and we can go ahead and hover over it and get that specific usage or stats of that particular period of time. What I can actually do is go ahead and click on one of the specific hosts and get that same stats for that, just for that particular host as well too. And I can actually go ahead and click on a particular disk and get stats on that particular disk as well too. Now, another thing here is over on analysis screen. Because we're so deeply integrated in both the hardware, the hypervisor, and the virtual machine itself, we will actually collect all the stats from all that. And here with analysis screen, I can actually go ahead and analyze what issues I had, or what performance issues I had, or all the stats I had from all my previous screens of hardware, virtual machines, and hypervisor as well too, and then correlate that into a single pane of glass here. And I can go ahead and use this date range time picker, pick a specific time period that I was having issues with, and here I can actually see if there were any alerts with the system. And as you can see here, like maybe there might be a disk that went down, a host that went down, or something happened. And then here I can actually go ahead and choose what specific entry I actually want to put on here. So by clicking on the new entry chart here, I can go ahead and choose something here. I'm going to say, oh, I want to see what my host is doing. And I'm going to go ahead and choose a host. And then what particular metric that I want to go ahead and choose. And say, oh, I just want to see what my physical CPU usage is. Go ahead and save that for the particular host, and then it's going to pop up here on this particular screen here. And then so we can go ahead and use this to actually troubleshoot if we're having issues with any VMs that have, let's say, a performance issue. Whether it tells us whether I'm having issue with it with a CPU, the VM itself, or a CPU within the host itself, or the entire cluster itself, or the network itself, or maybe a disk issue itself. And what used to take me 5 or 6 different consoles from different manufacturers, I can now actually correlate that into a single console. But let's go over to the VM side really quickly. Actually, wait, before I do that, let's go over into the alerts page, actually our health page. That's where I want to go. And this actually gives us an overall view of the entire health of the system. And we'll actually go ahead and help us troubleshoot what's having issues. And so at this point here, I can see that I've got something that's red over here. And this red means I've got some CVMs that got rebooted. And these things got rebooted today, obviously, because I just created the cluster. Okay, so because we're running the Acropolis hypervisor, we do have we can actually completely manage all the virtual machines within our Prism interface here itself. So since we don't have anything here right now, so this is where we actually go ahead and configure the network for all of the ESX, so all of the Acropolis HV hosts. Now there's actually just centralized network configuration where we actually go ahead and create this network, and it actually applies to all the AHV hosts for me automatically. So very similar to how VMware has for distributed virtual switch product, where we can actually go ahead and manage one central distributed virtual switch that then go ahead and applies down to all the ESX hosts individually. So I can go ahead and create a new network, and we'll call this particular VLAN 10, and here we can actually give it a VLAN tag. So we can give it VLAN 10. Now part of the network, actually, we have the ability to enable IP address management. What this basically means is that we actually can have Prism itself run a DHCP server and dynamically assign or statically assign DHCP servers to individual virtual machines. So we can do it basically have your virtual machine set to dynamic DHCP and then statically assign DHCP addresses over to the virtual machine. So it's a very easy way to centrally manage a lot of IP addresses for a lot of virtual machines as well too. But I'm going to actually go ahead and turn that off right now. And then, all right, so now I've created a network. Let's go back and try to create that VM one more time. All right, so we'll give it some RAM, some vCPU. We're gonna give it a disk. Now we're gonna actually add a NIC to it. And we're gonna click on save. We do have the ability to run customized scripts. So if we actually want to go ahead and have a fully scripted configuration for it, we can actually go ahead and do that. Click on save. All right, so we can take a look at what's going on the VM tasks. And here we see that all right, so it looks like our VM is done. Here's our VM. We now can go ahead and power on this VM. And then let's go ahead and launch a console. All right, and here's our console for this particular virtual machine. Now at this point we can go ahead and install the operating system and then go ahead and start deploying VMs. We also have the ability to our image configuration. So here we can go ahead and upload our ISOs that we want to use. Let's call this like our Windows 7 ISO. You go ahead and choose ISO, put it on a certain container, or you can upload it from a URL or directly from your own computer. Let's go ahead and upload this ISO for Windows. All right, so let's go ahead and, oh, one other thing is that we actually have built-in 2048 game into the BIOS of the VM itself. So that way, while you're waiting for your ISO to load, you can go ahead and have a little fun. Nice little Easter egg on here. All right, so while that goes, let's go ahead and open another console to this. All right, let's see. So we also have the ability to expand a cluster. Now, if we had another Nutanix system that was not configured as a part of another cluster, already powered on and connected to the network, we'll actually run an automatic discovery protocol and sense and discover that particular node that's unconfigured out there. At that point, we can actually use the expand cluster ability to go ahead and choose that particular node and give it the IP addresses, and it's going to actually go ahead and image it and then configure it and add it to part of the cluster. When that happens, we're actually going to go ahead and automatically expand our storage pool by adding those resources. We're going to expand our container resources. Then at that point, you would then add it to your hypervisor manager. If you're running AHV, it automatically does that. If you're running Hyper-V or ESX, you would then go ahead and add that server into your existing management server, and then you would now be able to go ahead and provision VMs to that at that point.
I think I missed the part of the conversation about containers. What kind of containers do you support?
So containers I'm talking about are what we call containers over on our storage page here.
Oh, okay.
Yeah, not
So,
not Docker containers or anything like that.
So
Yeah.
do you support containers?
So we do support containers by putting them in a VM.
All right.
Yeah.
All right.
Actually, so you probably see something about more containers sometime down the line, probably during the .next announcements. What I've seen is most likely we'll be starting supporting containers as a management function within Prism itself. And then you should be able to manage containers very similar to how you manage virtual machines at that point.
Yeah.
All right, so there's also the upgrade software. So this is our one-click upgrade. Now what this actually do is actually go out over the internet and see if there are any updates available to download. And at that point, it will actually show up here. You can go ahead and choose to download that, and then go ahead and install the update. And this will actually upgrade the entire Acropolis operating system. That's all the controller virtual machines on the machine. And actually go ahead and upgrade it on a rolling basis. So upgrade it one by one on a basis. What we'll do when it actually does a reboot, we'll actually go ahead and redirect the writes that normally would go to that controller virtual machine onto another controller virtual machine on the network. So that way you don't lose access to your storage for your virtual machines. Your virtual machines also don't suffer an HA event and don't have to vMotion off that host. All it is will redirect the writes, and your VMs will keep on humming like nothing ever happened. And at that point, we'll go ahead and upgrade that controller virtual machine one at a time for the entire cluster until all the controller virtual machines are done. And at that point, your entire Nutanix cluster has been updated for that particular version. So that's our one-click rolling upgrade feature. We also have that feature available for the hypervisor itself too. So we can actually go ahead and upgrade the hypervisor on a very similar one-click update. Go ahead and upload the hypervisor version over on here, the new version, and it'll actually go ahead and vMotion VMs off that particular host onto another host. Go ahead and upgrade the hypervisor, and then once it's done, we'll go ahead and go on to the next one and move the VMs off again, on and on, in a rolling fashion until the entire cluster has been upgraded. We also have the same thing for firmware. So firmware the exact same way, as well as our NCC and our foundation software as well too. Again, all via one-click upgrades, automatically downloads. Let's see. So, and here we can actually go ahead and with one click of the checkbox enable HA mode, and then that way we can tolerate failures of an entire host and have the VMs restart that on a different host as well too. There we go. One other thing is that we do have Prism Central. This is actually where you actually register Prism Central, or our new name for that now is actually Prism Starter Edition. And Prism Starter Edition is where we have our multi-site management of Nutanix clusters. So let's say you have a couple of different sites, maybe 5, 10, 15, 20 of them with a Nutanix site, a cluster on each site. Now with a Nutanix Prism Starter Edition, we can actually go ahead and manage multiple sites together under a single pane of glass, and have the ability to manage the entire network of data centers very easily under a single pane as well too. Also over in Prism Starter, in our Prism platform is our Prism Professional that also has. Yeah, tell me about it. Keeping track of these names is actually kind of difficult. Prism Pro will give us the ability now to add capacity analysis into the Nutanix platform as well too. So we'll actually go ahead and do predictive analysis of the actual Nutanix platform and tell you how much runway you have before you run out of CPU resources, before you run out of memory resources, before you run out of storage resources, and then tell you exactly which models that you would need to actually go ahead and correct those issues. So let's say you're running out of resources in about 30 days, it'll go ahead and suggest at that rate that you've been consuming resources, it'll suggest this particular model number for you to actually purchase and add into the cluster as well too. There's also what if analysis. If you get a new workload coming in and you go ahead and plug those resource requirements in there, and then it'll actually go ahead and update that analysis and tell you what if you have enough resources on your cluster, and if not, what models you need as well too. There's also right sizing VMs, so whether they're oversized or undersized, I'll actually go ahead and analyze that and suggest the configuration for that virtual machines, as well as detect zombie VMs or VMs that haven't been used with very little CPU, memory, or disk access, and suggest those as possible VMs that you can actually go ahead and delete because they're not being used as well too. That's over on our Prism Pro product, which our Prism Pro product is actually a separate licensable feature on Nutanix, although the Prism Starter is actually free with all editions of the Nutanix Acropolis operating system itself. Okay, let's see here. Here we can actually set up authentication. So we can authenticate against Active Directory or LDAP servers, and by entering the directory information and or groups, and then set security levels on a per group or create local users as well too. And with here, with role mapping, we can select certain groups that we actually want to give access to. Here is the alert email configuration. So here is you can add additional email addresses for alerts, so basically your rest of your administrators can get the same alerts. And here you can actually tell whether or not to send support alerts back to Nutanix as well too. Let's see, over here is our licensing page. So this is where you actually go ahead and manage your licenses for Nutanix itself. You go ahead and enter your or upload your license that you have or your license keys. You can go ahead and set your name servers or DNS servers for the Nutanix cluster here. Make sure that you set your NTP servers as well too, because NTP is required on the Nutanix platform. You have to make sure your time is consistent across all the virtual machines.
Can you talk about snapshots, backups, versioning?
Okay, great. All right, so there is the data protection page. forgot to go into. Actually, let's talk about snapshots real quick. So with the Acropolis hypervisor platform, we can actually take snapshots basically at will. And these are copy on write snapshots. So they're basically metadata-based snapshots. All these snapshots point back to this common block itself, so we're not taking additional space for additional snapshots. These are also copy on write. That means all new writes go over onto a new block. So these snapshots are both readable and writable. This is actually how we actually do our cloning as well too. So we're cloning for templates or cloning for VDI instances. They're all snapshot-based clones, which also means that cloning actually becomes extremely fast because they're just a couple of seconds, so they're just snapshot-based clones basically. We can go ahead and take snapshots and give your snapshot a name. Here we can actually go ahead and migrate, or basically do a vMotion. I could have it automatically select a host for us, or we can actually go ahead and choose a specific host that we actually want to plug it into. Here we can actually go ahead and clone a particular virtual machine and give it additional name, additional virtual CPUs, memory, disk, etc., etc. And actually edit the virtual machine and change the setting as well too. Data protection page. So here we can actually go ahead and set up our asynchronous disaster recovery or asynchronous replication over onto another Nutanix site. Or we can also set up our cluster. Sorry, this is our Metro cluster ability for synchronous replication over onto another site. And we can actually go ahead and set that up over here as well too. By clicking on the plus remote site, we would first define the site. Now this site could be another physical Nutanix site or a cluster, or an AWS cloud instance or Azure cloud instance as well too. And we can actually go ahead and use that AWS or Azure cloud instance today for backup purposes. And our backups are actually snapshot-based backups, where we can actually go ahead and take a snapshot of the VM and replicate that snapshot over onto another Nutanix site or up into the AWS or Azure cloud for backups as well too.
So you do not allow NFS or anything else that's open?
No. It would be all contained within the Nutanix system itself. But if we wanted to go ahead and create another site, we would just give it a name, choose what type we want it to be, either a backup site or disaster recovery site, and then give the IP addresses of that other site. Let's see if it lets me create a dummy site or if it'll error out. Oh, it's going to error out. Nope, there it is. It actually did create it. You can actually go ahead, when you create your site, it can actually enable bandwidth throttling. And you can actually compress the data as it goes across the network as well too, to save space, to save bandwidth over a WAN link. Also here, you can actually go ahead and select your vStore mappings. So we can actually map our container on the source side into another container on the remote side as well. The next thing we do is go ahead and set up a protection domain. And so a protection domain is a collection of your virtual machines that you want to go ahead and either synchronize, replicate, or back up all at the same time. And so you go ahead and create a protection domain. And at that point, you go ahead and choose which virtual machines you want to select. So I'm going to go ahead and select this guy over here, and I'm going to add it over to the protected entry side. Click on next, and then create a schedule. So with the protection replication schedule, we can have it repeat X number of minutes, X number of hours, X number of days, certain days of the week, certain dates of the month, and then go ahead and have it start and or end in certain time periods as well too.
No, I'm getting the camera, but is there a retention policy too?
Retention policy is actually set over here. We can actually go ahead and set how many snapshots you keep on the source side, how many snapshots you keep on the remote side, and we have multi-site replication, so we can actually go ahead and replicate from a single site out to multiple sites, or multiple sites down to a single site as well too. Click on close, and that sets up the replication schedule, and that's how you actually go ahead and set that replication for VMs. Very similar process to actually go ahead and set for backups as well too, snapshot backups. What's new in our version in 4.6 is our file server. So we actually have a built-in scaled-out file server as a tech preview in here in 4.6. What that means is we could actually go ahead and launch VMs, basically act as a SMB file server for your clients. This gives us the ability to have this, and this is actually distributed across all the controller, across multiple hosts in the cluster. We can actually go ahead and expand the performance or capacity of that by adding additional file service VMs as well too. This ability to service mostly for VDI home directories or user data directories right now. This is still in tech preview today.
I'm very scared of object storage still.
You probably want to wait until it goes into GA for a bit before deployed to production.
I'll wait. I'll let you lose data.
And then over here on the right, we have our REST API Explorer. So this is if you want to go ahead and do some advanced Nutanix scripting or automation or data center automation processes, you can use our REST APIs. Any commands that you do via GUI can actually be done via REST APIs as well too. And here we actually have the ability to go ahead and run REST API command directly in Nutanix and actually get values of it. And this would be the response back from it as well too. So we also have our own NCLI command line application, or command line, and we also support PowerShell for scripting as well too. And once you're done configuring your Nutanix cluster and configuring all your virtual machines, and you find that you actually have a lot of time in your hands because what used to take weeks to months now literally take hours, you can click on the nothing to do and run your 2048 little game as well too. And so that's pretty much the GUI tour guide, or tour of the Nutanix system.
Did we talk about virtual network?
Virtual network, yes. So that was back when I was doing the...
Well, I just didn't hear half of it. So.
So that's under the network configuration here, where we can actually go ahead and create networks. Okay. I'm trying to think here. Let me make sure I got everything. Home, health, PM, storage, hardware, file services, ear protection.
Really the last piece.
I'm sorry?
The networking was the only piece that I
Okay. Oh, one other thing is actually the search. I almost forgot about the search. So our search is context sensitive. So we can go ahead and type in something like the word create. And it'll actually go ahead and we can do things like create a container, create a protection domain, create remote sites. If I actually go click on create a container, it'll bring me directly to create a container page. I can also use this to go ahead and search for my virtual machines. And click on that and it'll take me directly to that virtual machine or host or container or whatever basically.
Very nice UI touch.
Okay, I think that's pretty much it.